Please, I need 1000% focus and fast. Thank you. So there will be no side talks, please. We want to build more, we want to have more background before Bayes' theorem. Before we have done conditional probability, right? So we agree that the probability that A occurs given B is the same as what?
Probability of A
Divided by?
probability of B.
And this is when A and B are what? What kind of event?
Dependent.
Dependent. Because that's only if they depend on each other, right? If they are not dependent events, then they are independent, right? So if they are independent events, by conditional probability, if A and B are independent, then what is the probability of A given B? Say that again. Probability of A. Right? Also, what is the probability of A given not B? What's the probability of A given that B does not occur? Still probability of A. That's the whole purpose of independent. Right? Similarly, probability of B occurring given A will be what? Probability of B. And probability of B given that A has not occurred is what? Probability of A. Right? Oh, probability of B. My bad. Sorry. Okay. So I'm just going to focus on maybe this and this. Let's look at this because it's just the same. Okay, I can write 2. These are our deductions. Okay. Normally, this would have been this one from 2 by definition of conditional probability. Should have been probability of A given B is equal to probability of A intersection B divided by probability of B for any A and B, isn't it? We have just said that this is actually the same as probability of A. Am I making sense? Because if A are independent. So from here, then A and B are independent if and only if, are you with me? If and only if this conditional probability end up giving us what? Say that again. Probability of A. And this will occur if and only if, so I'm now here. Okay? Because I don't have enough space. So normally I write this in one step, then introduce it in another step. Am I making sense? So this will occur if and only, or maybe we could get rid of this. I'm sure you understand. This is the conditional probability. It looks somehow. Okay? So this will happen if and only if my probability of A intersection B is the product of probability of A times probability of B. So we could say that this is how we actually derive that the formal proof of independence. So if I ask you to prove in an exam, prove that if A and B are independent, probability of A and B is the probability of A times the probability of B. I do not expect you to just say, oh, it's just because we know in class, or because we did an investigation. Mathematical proofs are not for specific situation. We have talked about that. It's in generalization. So this is the formal way you can show me. Now, oh, according to conditional probability, probability that A occurs, given that B had occurred, will be this fraction. And if A and B are independent, this is actually going to lead up to what? Probability of A. Then you cross multiply and boom, that's what you want to get. So but if the statement comes with if and only if, then show us the step of prove by what is this? Equivalence. This is how we do proof by equivalence. You are saying these two statements are the same thing. The statement that A and B are independent, and this statement are going to end up being the same thing. So you don't have to say, so suppose A and B are independent, and so you show this, then you say, oh, suppose this happened, then you use that to show that A and B are independent. You don't have to do that. Am I making sense, please? You're looking confused, are you? Okay, so with this now, we're now going to focus on some questions here. And towards the end of the class, there are some proofs. So examples of practice. So either way is fine. Question 1. The first question says, suppose, I expect the first one to be the easiest, so hopefully we are right. Otherwise, we are all in trouble. So write fast, please. Suppose probability of R is 0.4. Probability of S is 0.5. And probability of R union S is 0.7. The question is, are R and S independent events? Let's discuss this. I don't want to say, oh, I give you 5 minutes, well, we're not going to cover everything. So let's just analyze it together. What does this question want us to do? I'm clueless, help me out. And I need everyone to be part of this. It doesn't matter if what you want to say is rubbish to you, but you need to speak out. I need to make sure, I need to be sure you are contributing. Are they independent events? That's the question. So how would you begin?
Defines probability of A intersect B.
Is that what you're going to say? I saw your mouth move. You remove your face now, so I could see that you're about to say something. What killed that confidence, Krista? Okay? When I bring chocolate next time, I won't be confident to put it on your table too. It's going to be give and take. So all you have to do is find probability of the intersection and see if it is the product of these two. Right? How do we find the probability of intersection?
KRUS.
Let's hear from her this time.
Probability R union S. Probability of R.
Probability of R.
Plus probability of S minus.
Exactly. Be confident means. Okay? So you start from here. Try to find the probability of the intersection. So, this you know, 0.7, 0.4, 0.5, then the intersection you're looking for, so it becomes positive. So this is 0.9 minus 0.7, which is 0.2. Now, is the product the same as 0.2? Check. 0.2 is 20%. Is 0.4 times 0.5 20%? Understand? So, since probability of R times probability of S, which is 0.4 times 0.5, which is 0.2. Of course, this is the same as probability of the intersection. It implies that what? R and S are indeed independent. That's all. The question never said work out the probability of intersection. You should be able to know, especially at this point in your IB program. how to trace things back to the source, how to be logical in your solution. All right? Quickly, I'll write the next one. We analyze it together again. Let's pick question 3 from you. I'll put the page number, so I'll send you a screenshot later. Page 279/280, exercise 11J. So question 3. It's a long question. Does everybody have the textbook here? No. Okay, never mind. I can send a screenshot. So, okay, yeah. Okay. Do question 2 instead. I can see write that on the board. It's not so long. So you start with that. Suppose probability of A equals 2/5. Probability of B equals 1/3. And probability of A union B is 1/2. The first question is find probability of A intersection B. Question 2, probability of B given A. Question 3, probability of A given B. And the last question says, are A and B independent? Independent events. Justify your answer. able to do number 2? Is that number 2? Okay. Karen, stop copying notes in the class. You could have left the space. How am I supposed to know if you understand something if you don't even practice 10% of the time? Stop copying notes in the class. That's number 2. Number 2? To a sense. I'll stop you in 2 minutes, please. Then we'll look at number 4 and 7 together, and I have also number 8. Any number that I miss, I need it done. I want to see tomorrow. So I missed 3, I missed 5 and 6. I'll send you screenshots of the notes of the textbook page later. Notes will be sent to the group. So please stop copying notes during lesson, especially during practice session. So the next after this is base theorem. All right, I'm up for number 2. Let's focus on the right. So I believe it's easy to find probability of A intersection B, right? You just go to your addition formula, right?
Yes.
Then B, given A is easy. You already have your intersection, right?
Yes.
And you have your probability of A. Also, A given B, you have your intersection, then you have your B also, right? Then you can confirm their independence or not by observing this and the product. Is that what you did? Great, okay. So I'm not going to ask you how that went. I'm sure that went well. All right, let's focus on this. Are you done? Thank you, sir. A and B are independent events. Prove that A prime and B prime are also independent. I think this we already know. That if you go to school tomorrow, does not affect the fact that I come to school tomorrow. You don't go to school tomorrow, does not affect the fact that I don't come to school tomorrow. We know that. Again, the fact that she comes to school tomorrow does not affect my coming to school and does not affect my not coming to school. If she doesn't come to school tomorrow, does not affect the two possibilities also for me. So this is something we know. That if A and B are independent, their non-occurrence must also be independent. But how do you prove it mathematically? So the question to the class. You go to the IB exam and the question says, if A and B are independent, prove that A prime and B prime are also independent. What is the first thing that should come to your mind? How would you begin? Let's scribble the solution. Let's look at these three together quickly. You have like 25 minutes. Yes, what will be the first thing to do? Anything that can fetch you 1 mark, you have to write it down, even if it is not the solution. All right? So what is that thing that you want to think about for that you think you should write down?
A plus A prime equals 1.
Say that again?
A plus A prime equals 1.
Yeah. Okay, so what with that? A plus A prime is not 1, by the way.
Oh,
A is a set. We will need that later, but not now. Yes?
Write what it means for A and B.
Speak louder, please.
Write what it means for A and B to be independent.
Good. You already been given that. At least write down what that means. So Karen, what does it mean for A and B to be independent?
Probability of A.
Okay, so I will start by saying, oh, since A and B are independent events, please write that in full, okay? Probability of A intersection B must be probability of A times probability of B. This is all we know, right? Now, what do we want to show? Brandy, what do we want to show according to this question? Maybe when we know our destination, we can know how to get there. What is that thing you want to show, Brandy?
A prime and B.
Sit louder.
A prime and B.
We don't want to show A prime and B prime. Don't speak casually like this is a chat. I'm asking you to write a formal letter. You're not going to communicate like you're chatting, like your friend knows what you're saying. So you need to speak to me what you want the examiner to see.
Oh, the probability of A prime intersection B prime equals to probability of A prime multiplied by the probability of B prime.
So this is what we want to show. So stop being informal. You have to be formal all the time. This is where we are going. The question is, how do we get here? And this is all we know. Maybe we just put prime on everybody. Do everybody go home? But it doesn't work like that. Any clue? I'll give you some steps. Probability of A prime intersection B prime is there a way you can express this set? Lillian, any idea? See, some things that you learned in the past you think are not useful.
Probability of A union B prime outside.
You learned that in Form 3, I'm sure. What is this law called? Start with a D. There's M in the word. There's G in the word. Are you kidding? Come on, D. Morgan's law. You don't remember the Morgan's law anymore? X intersection Y all prime is equal to what?
X prime. Union.
Wait, You don't know De Morgan's law, raise your hand, please. Because if you know, then you shouldn't be quiet. Unless you don't know. Okay, so I expect 2 or 3 people to be quiet. Then the rest has to say something. What is X intersection Y all prime by De Morgan's law? X prime, union, Y prime. You just do the opposite of everything in the bracket. Opposite of X is X prime. Opposite of intersection is union. Opposite of Y is Y prime. And similarly, X union Y all prime is what? X prime. So this is by De Morgan. So we call this De Morgan's laws of sets. De Morgan's laws of sets. And it can extend to more than 2. Okay? So you can use De Morgan's law first. How can you express this? Somebody said something. Oh, I thought I heard something. I thought I heard what I wanted to hear. Yes? 1 minus. I knew I heard 1 minus somewhere. 1 minus what? Probability of A. No, we don't write all here.
Union.
Union. You don't know what union is? Does everybody understand that? Is there a way we can express this further?
1 minus probability of A.
You need to speak louder, sound fast.
Probability of A minus probability of B plus probability of A intersection B.
Does everybody understand that? We appreciate brackets first. Okay? So that this is 1 minus probability of A plus, no, minus probability of B plus probability of A intersection B. What next? Everybody should be able to participate now.
From probability of A intersection B equals to probability of A times probability of B and A will be.
So we use the independence property now. So we get probability of 1. Remember, this is what we are trying to simplify, and we must get this. So 1 minus probability of A minus probability of B plus probability of A times probability of B. What next? This is A prime, right? It looks like it, but how can we make sure times comes in? You can look back and forth, back and forth. Yes, sir.
You can. It kind of looks like.
Looks like what?
Two
words.
A plus B times.
What is the word?
Quadratic equation.
No, we use that word in quadratic equation. It looks like something. What is the action we have to perform?
Factorize.
Factorize. Factorize. What is the common factor that you can see?
1. Wait. No.
Something you can factorize first.
You can factorize.
P.
Say that again.
Probably.
I didn't hear you. What?
Just P.
I can't hear you, Brandy. Sorry. Because of the mask, you need to speak louder.
P.
P. It's not, what do you mean P? P is not even a variable.
You can factorize 1.
Are you kidding? No, not like that. What can we factorize? Everybody look. Probability of B. Thank you. So what do we get?
1
1 minus